Welcome back. In this video, we're going to get that ball to react or to bounce off the paddle. So where we left off last day was, let's see here. Okay, there we go. So we've got our title screen. We click to the next screen. We press any key and the paddle moves. And I've actually coded it where it does bounce. Again, mine's a little bit slow. It's probably because I'm using a graphic for the ball. My timer is already at 1 millisecond. What I could do is increase my dx and dy to get that ball to move faster. Just be careful if you are doing that. Whenever you increase dx and dy, if you make it too large, it could overlap the collision areas like the walls or the bricks or the paddle. So just be cautious of that. Okay, so how did we make this work? Well, we are going to go to the ball class. Just zoom in here a bit. And at the bottom, we're going to make a new method called collides with. Okay, so this is a void method, and it's going to accept a paddle object as a reference. Now, the cool thing about this is if you wanted to make a second paddle, like a second player, maybe at the top of the screen or the bottom, you could pass in that other paddle into here. So this would work with any paddle that you've created in your Brick Breaker game class. Right now, we just have one paddle, so we're just going to keep it simple. But if you want to add that enhancement, you can feel free to give that a try. Okay, now, many years ago when I first started doing collision detection, it was quite difficult. You had to check the x coordinates of the ball and see if it's in between the x coordinates of the paddle, and then same with the y coordinates. So we had many if statements. And then I discovered that Java has a built-in class called rectangle. Now, this doesn't actually draw a rectangle. It just creates this kind of abstract rectangle. And what you do is you create a reference, and then you use the new keyword. So you're calling the rectangle constructor. And then you're just passing in a top left corner and a width and a height, and that will create a rectangle. So what I'm doing is creating this virtual rectangle that surrounds my ball. And so the top left corner is going to be x, y. Okay, what is x and y? That's the x and y of the ball. Okay, that's precisely the instance variable of this ball object. And then the width and the width of the rectangle and the height of the rectangle will be size. And again, that is an instance variable for the ball. Okay, so this is the ball's XY position and the ball's size. And so I'm just putting a virtual rectangle. You won't see it, but it's gonna always be surrounding the ball. Likewise, I'm creating a rectangle object that surrounds my paddle. So I'm creating another new rectangle and storing it into a reference called paddle. And the x and y are going to be the x and y of my incoming paddle. Okay, so we're going to say p.getx, p.gety, and then the width and height will be the width and height of the paddle. Okay, so every time the ball moves and the paddle moves, there are these kind of virtual rectangles surrounding the ball and paddle. Now, why are we doing this? Well, there's a really cool method that is part of the rectangle class, and it's called intersects. And this will give you true or false. This is a Boolean method, and it will tell you if any part of this rectangle intersects with any part of this rectangle. So we simply now have to say if ball, okay, again, what is ball? It is a rectangle reference or a rectangle variable. So we're saying if ball.intersects paddle, then we're going to change the y direction. You can get fancy with this. If you want, you can add another if statement inside here that also changes the x direction. So for example, I've seen some Brick Breaker games where if you hit the left side of the paddle, then the ball goes in the opposite x direction. And likewise, if it hits the right side of the paddle, then the ball is kind of deflected back to the right. So as a challenge, you could do that in there. You could even I've seen people make a random number inside here, and so the dx might randomly change. You could even change the dy to be at a different angle, or you'd have to change the dx and the dy to make the ball kind of bounce at a different angle. So this is the simplest thing to do here, is just simply change dy. Now, where are we going to call this method? Well, we go back to the Brick Breaker game. This is kind of our controller class. And inside the draw game screen, okay, we're drawing the background. We're going to move the ball, and that also in turns draws the ball. We're going to draw the paddle, and then we're going to say ball dot collides with paddle. Now, in this class, ball is our actual ball object, and paddle is our actual paddle object. Okay, but that's all we have to say. And so every time the timer ticks, so every 1 millisecond, this code is going to be called upon, and we're always going to check for collisions. So we're constantly doing that. Now, there's one kind of glitch that maybe I can try to reproduce here. And that is if you make a side contact with the ball. Okay, so if I hit it kind of flush right on the top, no problem, looks good. But if I kind of hit it on the side, let's try that again. Let's make it come off. There. Okay, so what's happening there is the y pixel of the ball is, I think my y pixel is 5. So basically every time the ball moves, it goes 5 pixels in the y direction. So it's actually going through the paddle, and then it's bouncing off, but the y value is still within the paddle. So it's changing y directions again. So it gives you kind of that stickiness. It's the dy keeps changing from positive to negative until it kind of disconnects from the paddle. So we can fix that by going back to the collides with method in the ball class. And not only are we going to change dy to negative dy, but I'm going to snap the y value of the ball. I'm going to do y equals y minus 5. Okay, this works for my game. You might need to play around with that number. It might look weird if you make it too big, or it might not fix the glitchiness if it's too small. But this, I think, is a good value for mine. So what this does is as soon as the ball intersects with the paddle, it just pushes the y value of the ball ever so slightly to the top of the paddle so that it exits the paddle and doesn't kind of get trapped inside. So let's have a look at that. And if you try and reproduce that glitchiness, it should look a bit better. Yeah. So, I mean, it looks a little bit weird. It's kind of floating kind of right through, but at least it's not getting that up and down. Yeah, a little bit interesting. Again, you could have fun with this. Like you could add if statements so that if it's a side collision, you actually make it kind of bounce to the side. So whatever you would like to do. Okay, so now what I would challenge you to do next, I'm not going to do it in this video, I'm going to leave it as an exercise for you, is to make another class here called Brick. And Brick is actually going to be very similar to the paddle class, except that the paddle or the brick would not move. Like they're gonna stay still. I mean, I guess you could make an enhancement where the bricks move. I did have a student one year make kind of like Space Invaders, where the bricks would go down every 5 or 10 seconds, and so you had to get rid of the bricks before they all came down to the bottom. That was kind of a challenging task. So yeah, try to make a brick class and just try to start with one brick. So in your main Brick Breaker game, create one brick object and draw it, and try and make the ball collide with the brick. And when it does, it makes the brick disappear. Now, just as a hint as to how to do that, step 1, create the brick class. Step 2, create a brick object and draw the brick inside Brick Breaker game. And then step 3, in the ball class, you're going to make another collides with method but you're going to make it so you're going to you're going to overload this method. So you can literally just copy and paste this, but then make this a brick object coming in. Okay. So that's a start, and then you have to change kind of the code that's in here because you have to make it respond to all sides of the brick. Okay, I'll leave that as a challenge, and then hopefully you can do that before the next video is uploaded. Okay, ask me any questions if you have any, and good luck.